In this course, I'm going to teach you guys everything you need to know to get started in Python. I designed this course according to the workflow of a typical data science project, which involves data collection, data preprocessing, data explorations, model development, and model evaluation. And each lesson has been designed with example that will help you along the way and help you get familiar with the key concept. Anyway, I hope you guys stick around with the course and learn this amazing programming language. So let's start to build your first Python program. I will show you guys how we can use Python instructions or some Python code in order to show a message on the screen. Over here, we can print something out on the screen and Python using something called a print statement. So I can just type out print and inside of the parenthesis or round brackets, I can just type quotation mark and inside the quotation mark, we can put whatever we want to print out on the screen. So I'm going to print a hello world statement and here, and then click the one button and execute it. You can see down here, we are actually printing out this hello world message. So essentially what Python is doing when I click the one button is that it's going into the file and looking all of the instruction in order. In other words, Python is actually going to execute the lines of code that we write in order. Therefore, the order of the instructions matters a lot. The next thing that I want to talk to you guys is types of objects. Python is an object-oriented language, so there are many types of objects in Python. The most common types are string, integer, float, and boolean. Before we go into the details, let me explain a bit of a Python variable. Like other programming language, variables are like containers for storing data values. However, unlike other programming language, Python has no command for declaring a variable. A variable is created the moment you first assign a value to it. So let's say, for example, here we create a variable called x, and then that is equals to 1. And similarly, x equals to 1.234, x equals to hello world, and x equals to true or x equals to false. So by assigning x equals to 1, that means we are going to assign x variables as an integer. So similarly, here we assign x variable as a float number, as a string, as a boolean. So let me assign a better name to them in order for me to show you the use of the types function. You say, for example, assign integer. This is the float number. This is the string. And this is the boolean. And here you can see that the integer, the class is integer. That means the type is an integer. Similarly, we can print the other types. So for example, the float number, the string, the boolean. So here are the results. You have the integer as an integer class, as the float number as a float class, a string as a string class, a boolean as the boolean class. So for example, if we want to change the integer to float, integer to float, we can use the built-in functions called float, and then type the variables inside this parenthesis, and then can just print out the type of this new variable. You can see here the type is changed from the integer types to a float type. Similarly, we can also change the, say for example, change the float type to an integer type or the string types. Say for example, we just copy this floats number, and then we change the floats to integer by using the integer function. And also we can use the float to string by string function. And let's print out the result. Over here, you can see the result. The float originally is a float number, now has been changed to an integer number by using the integer function. And similarly, we can apply a string functions to change the float number to a string. And of course, we can change the string back to an integer or float as long as this string is an integer or float number. Say, for example, we have our integer number 1, 2, 3, and then we can just apply an integer function, and then we can change it back to from a string back to a integer number. So here you can see that the string has been changed to an integer by applying the integer function. The next things that I'm gonna show you is the basic mathematical operations. Python supports all of the math operations that you would expect. The basic ones are addition, subtraction, multiplication, and division. Let's go through some example to make everything clear. So for example, we have x equals to 2 plus 5. First print out the x. Got the result 7, change to minus. Got the result -3. And then say for example, if we would like to perform multiplication, we just change the symbol to asterisk and then just run it, and then we get the result 10. And say for example, if we use 10/5, that is the division, got 2. We can also use double slash to get the quotient. And on the other hand, we can also use percentage to get the remainder. In addition, we can also use double asterisk to perform a power function. So for example, 2 to the power 3, just use double asterisk. Apart from the basic mathematical operations, we can perform some basic string operations. They include indexing, slicing, and strike. So for example, we have a string variable. Similarly, we call it x, but the string is Python. And then we can use positive indexings to call out each of the letter. Say for example, P square bracket and then 0. So what it means is that we are using the positive indexing, and positive indexing is starting from 0 from left to right. So the P is the 0, Y is 1, and P is the second, and so and so. So here we just use a square bracket and then put the index 0 right here to call the letter P. So we got a pre. Similarly, can also print out the other letters. So we have 6 letters here. So 0, 1, 2, 3, 4, 5. So these are the results. We can also use negative indexings to pull out each of the letter. So the negative indexing starting from -1 from right to left. So this is -1, this is -2, this is -3, -4, and so and so. So -1 is the N, -2 is the O, -3 is the H, and so and so. So these are the results. We can also provide a range for the indexings in order for us to obtain multiple letters. Say, for example, we just use 0, and then we use a colon. That means we are providing a range to it. So, say for example, 0 to 6, that is the end of this string. So what it means is that we are going to get the letters from P to N. But remember that N is actually the X5, that is the position 5. However, we always have to add 1 to the N. So here we get the Python by using this slicing function. Similarly, we can also get the first 3 letter and or the last 3 letter, or we can just provide a colon here to get everything. So here are the results. But let me repeat it again. We always have to add 1 at the ending positions. Here, n, the position of n is 5. However, we need to add 1 to it, so we give a 6 here. We can also use strive to select every x character from this string. Say, for example, we have a full string here. We just need to add a colon here, and then say for example we want to select every 2 character from this string, and then we just provide 2, and then if we want to select every 3 character from this string, and then we can provide 3 or so and so. Similarly, we can also get use a colon here. This means we need to get the full strength here, and then an additional colon means that we are going to apply strive, and then these 2 means that we select every 2 character from this full string. So here is the result. We can also use the basic mathematical operations to perform some basic string operations. Say, for example, we just use x plus x, and then you will get 2 strings that combines together. And say, for example, x times 2 should get the similar results. Lastly, there are 4 commonly used string functions that I would like to go through that include upper function, lower functions, replace function, and find function. So the upper function will return all the characters inside these strings to a upper letter. So here is the result, and this is the function. And similarly, the lower function just return every letter in this string into a lowercase. And the replace function is to replace the characters inside these strings into a new string. Say for example, we have a 101 here. That is what we would like to replace in this string. And then we just type in the functions as replace. And then there are two arguments. The first argument is the string that we would like to replace. And then the second argument is the new characters that you would like to replace with the uh, existing string. So here you can see that the Python 101 is changed to Python 202. And finally, the find function. The find functions can help us to find the substring inside this full string here. Say for example, we want to find the on right here, and then we just use the find function, and then the first argument is the on here. We do not have that's the only arguments here we need to define. So the find function will return the substrings, the first letter positions of these substrings that is on. The first letter means here on, this O. So this is 0, 1, 2, 3, 4. And that is the first positions of this substring. The next thing that I'm gonna go through is the data structures. So data structures are basically just that they're structure which can hold some data together. In other words, they are used to store a collection of related data. There are 4 built-in data structure in Python that include list, tuple, dictionary, and set. And by using different brackets, we can assign different types of the data structure. Say, for example, for tuple, we will use the round bracket, and for list, we will use the square bracket, and for dictionary, we will use the curly bracket, and similarly for set, we will use the curly bracket. So let's go through them one by one. Say for example, let's just create a list, a tuple. We have say for example, we have item 1, 2, 8, 8.9. By using a curly bracket, we just created a tuple. So can print out the results and can also print out the types. So you can see the tuples contain different types of data, and the class is tuple. Just like the string operations, we can also perform positive indexing, negative indexing, slicing, and stripe. So say for example, we can use the colon here to get all the elements from this tuple, and we can also use 0 here to get the first element, and similarly we can get the second element and also the third element in this tuple. And we can also perform the negative indexings. This is -1, -2, and -3. -1, -2, -3. So here are the results. Let me expand a bit of these tuples in order for me to show you how to perform the slicing. Say, for example, if we want to get the first 3 elements, we just type in 0 from 0 to 3. So this is the first element, that is the index of 0. and this is the second element, the index of 1, and then this is the third element that has the index of 2, and then we just plus 1, like what we've done in the string. Plus 1 at the end, we will get the first 3 elements. Also similar to the string, we can use strive to get the every x elements from this tuple. Say for example, we just use the colon to take all the elements here, and then we add one colons, and then to define how many x elements that we want to get from this tuple. Here we define 2. That means for every 2 elements we get from this tuple. So here you can see that this is the full list, that is this full list, and then this is the for every 2 elements. So we have item 1, 8.9, and 4. We can also perform some simple mathematics to the tuple. So for example, we use tuple plus tuple. We will just concatenate these 2 tuples together. And we can also use tuple times 2 to get a similar result. We can also use the sort function to sort the element inside this tuple. Say, for example, we want to sort this tuple, and we just need to use the sorted function and put the tuple as the argument. So we just print the result. So this is the result. However, you should be noticed that this sorted function will change the tuple into the list. So let me show you the type. So the class of this tuple will be changed to list by using this sorted function. So you have to be aware of that. The last thing that I would like to go through is a nested tuple. So that means there is a tuple inside a tuple. So for example, we create a nested tuple here, and then we just get 2 nested tuple here. So we have a tuple here, and then we have 2 tuple inside this big tuple. So that is a nested tuple. And similarly, we can also perform the indexing in order for us to identify the elements inside this nested tuple. Say, for example, we want to print out the item 1 inside this nested tuple. This item 1 inside this nested tuple. That should be the 0. And if we want to print out the second item inside this tuple, we just provide 1. Similarly, we can just print out the third item inside this tuple by using the nested tuple, and then should be 2 for this index. So these are the results. And we can also go deeper in order for us to identify the element inside this tuple. Say, for example, if we want to identify the item 2, the first element, we can just provide an additional index to this nested tuple function here. So we just one means this the first item here, and then the 0 is the first element inside this item. So similarly, we can get the second item inside this tuple. So that should be 2. Yep. And also the 8-point line. Yes. The last thing that I want to mention is that one major features of tuple is that they are immutable like strings. That's it. You cannot modify the tuple. So say for example, if we want to update these value, update these value to line, it is not possible in tuple. So therefore, tuple are usually used in cases where a statement or user-defined functions that we do not want anyone to change. Similar to tuple, we can use a list to hold a collection of items. However, unlike tuple, list is multiple data types. That means we can change the data inside the list. So first of all, let's create a list with different types of item by using a square bracket. We have item 1 that is a string, item 2 that is also a string, and then 3, 4, 5 that is a integer. So we can also use uh, positive indexing to identify the element inside this list. So for example, by providing a colon here, that means we get all the items inside this list, and 0 means this first item. Similar, get the second item, third item, fourth item, and so and so. So here are the results. We can also do the negative indexing. So for example, if I would like to get the 5 by using the -1, and also the slicing. Say for example, I would like to get the first 2 item. So here we go. And strive also work under list type object. Say for example, to get everything, every 2 item from this list, every 2 item that is the item 1, 3, and 5. And here are the results. We can also use simple mathematical operations to concatenate the list. Say, for example, list plus list. We just combine these 2 lists. And then say, for example, list times 2. And we just replicate the list. We can also use the sort function to sort the item inside the list. Use the sorted function, apply on this list, and here you can see the result 3, 3, 4, 4, 5, 5. Similar to the tuple, we can also create a nested list. Say for example here 3 and then 4, 5 is another list inside this inside the main list. and then we have another list that is 345 inside this thing list. So let's say, for example, if we want to print out the item 1 of the list, we just need to use the positive index, providing 0 right here. And if we want to identify the second item of this list, we just use the nested list and then positive index by providing 1 here. If we want to go deeper, just one level down, say for example, if we want to identify these 4, so we can just provide an additional positive index right here, that is 0, to identify these 4. So that's exactly what we've done in Tuple. Just like what I've mentioned, list is mutable. So say for example, if we want to update or change one of the item, that is possible. So just say for example, if we want to change these 3 to another value, say for example 9, and print out the result. So that should be, that is possible. The item 1 of the list is 9 right now instead of 3. We can also use delete functions to delete values in this list. So here you can see that the first item is gone, and then the first item becomes the 4, 5. This is the list inside this nested list. The next 2 functions that I want to show is the extend function and also the append function. For example, we have the nested list here. If we want to extend the list by 2 items, say for example, by item 1 and item 2, we will just put this function, the extend, is just similar by putting these 2 elements right here. So let me show you the results. So the extend functions here extend the list by adding all the items here into the end of this nested list. However, if we just want to add a single element to the end of this list, we can use append instead of extend. So here you can see that this is only one single element added into this list. Before we move to the dictionary, I would like to introduce another concept to you, that is the referencing and clone. So say for example, we have a list right here, and then if we just want to reference to create a list that is just reference to this list, and then we can just use a equal sign list. So that means if there is any change in this list, there will be a change in the list reference here. So this is referencing. However, if you would like to just copy or clone a list, so you have to provide a colon, a square bracket with a colon here. That means you're going to copy this list. So if there is any change in this list, there will be no change in this list clone. So let me show you an example right here. Say, for example, if we change the first element in this list, in the original list, you can see that the list reference is changed by the new item that we just assigned it to the original list. However, in the list cone, there will not be any changes. Now let's move to the next data structure, dictionary. A dictionary is like an address book where you can find the address or contact details of a person by knowing only his name. So here we associate the key as name and values as the details. Notice that their key must be unique, just like you cannot find out the correct information if you have two persons with the exact same name. And also notice that you can only use immutable objects like string for the keys of the dictionary, but you can use either immutable or mutable object for the value of the dictionary. So now let's create a simple dictionary. So say for example, we have a dictionary and we use a curly brackets to create a dictionary. And then we have a key one that contains the item one. And then we have the key two that contains the item two. That is the integer two. And then we have key three that contains a float number 2.3. So just say, for example, let me use the key 1 to access the item 1. Cool. We just create a dictionary. So here we need to remember that the key value pairs are separated by a colon here, and each of the key and item pairs are separated by a commas here. And then by using the curly bracket here, we can create a dictionary. So here, by using the key, that is the key one here, we can access the value of this key, that is the item one. On the other hand, we can also print out all the key by using the keys function. And also we can print out the values by using the value function. So here are the results. Just like what I mentioned before, the value of dictionary is mutable. So say for example, we can change the item one to a new item. So you can see that the value has been updated. And because of the key is immutable, so we cannot just update the key or rename the key name right array in a straightforward manner. However, we can use a pop functions to help us to do so. So say for example, we have a dictionary that a new key here, and then we just want to replace this key one, or we name it. So we need to use the pop function and then provide the correct key name here. So you can see that key one is gone, but right now we have an updated key. And also this new key is also associated with the item one. Similar to the list, we can use delete functions to delete the items that we do not want. Say, for example, if we use the delete functions to delete the key one, the pairs of key and value. So the key one and item one are gone. We can also use the sorter function to sort the key and also to sort the value. However, the dictionary will become leads. So the functions of the dictionary originally that we have is gone. Similar to the list and tuple, we can also create a nested dictionary. Say, for example, we have a key 2, and then inside this key 2, we have a 2, 1, and there's a value that is 2, 1, and we have a key 2, 2, we have a value that is 2, 2. And we can access the value by providing the correct key. So say, for example, we just access the item 1 here, and here we want to access to the 21, just say, for example, and we provide another key to. So here are the results. The final data structures that I want to talk about is set. A set is an unordered collection with low duplicate elements. Basic use include membership testing and eliminating duplicate entries. Sets are objects support mathematical operations like Boolean, intersections, and differences. We can create a set by using a curly bracket, or we can use a set function. So here we just use a curly bracket to create a list, a set. So we say, for example, we have the Python first item 1, and then that's 2, 3, and 1, and also have the class. So we just print out the set 1 here. And also let me show you the types of this set. So here are the results. When we create this set, we have a strength 1 and also a strength 1. However, the results in under the set that will show you just a one strength here. So that means under the set functions or under the set data type, they will just remove all the duplicate elements. And you can also see the class is a set here. We can also use the set functions to convert tuple or list into a set data structure. Say, for example, we have a tuple here, and then we can just type the set. We can just convert these tuples by using this set function. And similarly, if we have a list inside this set function, and then this set function will just convert this list into a set class. So let's see for the tuple first, and this is a tuple, and then by using the set function, we can convert it to a set. And similarly, we can convert a list by using the set function to a set. Under the set data structure, we also have the X function and also remove functions that allow us to add item or remove item from the set. So for example, we want to add a number 102 to this set, and then we want to remove the Python in this set. So we just use the add function and remove function. And that's it. Here you can see the results. So we just add 102 in this set, and then we also remove the Python from this set. So the main purpose that we want to use set is because we can use the logic operations. Say, for example, the intersections, the difference, and the unions. So let me show you a couple of examples to go through this function. Say, for example, we have a set that contains the Python lesson 101, 254, false. This is the set 1, and then we have the set 2 that contains the Python set these false 102. We can use a simple AND to find the intersection, or we can use a functions to find out the intersections between these two sets. So a simple AND or intersection by function, that is the set 1 dot here the intersections set 2. The idea here is that we have the set 1, that is our main object, which has been assigned as a set data type. And then under the set 1, we can call out the intersection function by using the dot intercept functions. And then just only one argument we need to put, that is the set 2. And let me show you the result. Oops, sorry. I need to print out the intersection. I also need to print out the intersection by using a built-in function. So here we go. The results are the same, and Python appears in the set 1 and set 2, and also the calls appear in set 1 and set 2. So these are the intersection. The next thing that I'm gonna show you is the differences. So here we can have a set 1 difference and then apply a difference functions here by calling the difference set 2. Similarly, we can do the same for the set 2. That is the set 2 difference, and this is set 1 and this is a set 2. Right here, the set 1 is the main object, and right here, set 2 is the main object. And let me show you the results first. So difference operation is used to identify the first set uncommon elements, and common elements will be eliminated after difference operation, and uncommon elements will be put into a new set. So here you can see that the common elements in set 1 is Python and cause. So that means we will put it, we will remove it, and then the uncommon elements that will remain in this set 1 difference. So this is the result. And then similarly, for common element in set 2, that is the Python and also the cause. So they will be removed, and then the uncommon element that is set, least, and 102 will remain in this set 2 differences. So of course, we can also pull out everything from these two leads to set by applying the union function. So say, for example, we use a set 1 union of set 2. The final two functions that I'm gonna show you is that to check whether a subset is under a set or whether there is a superset of this set 1. This is the result. Say, for example, and the results will return you a union of set 1 and set 2, which is still a set. iPhone calls, and then we have a superset here. Say, for example, we have a new item here. And then by using its subset functions, we can check whether this subset belongs to this set 1. So say, for example, we have a set that is a subset. And then to check that whether this is a subset of the set 1 is, we just apply the is subset and then put in the set 1. So that is what we want to compare. So this is the subset that we should put, and then this is the original set that we try to see whether this subset is inside this set 1. So that returns a true. That means this is one. The subset is a subset of the set 1. So for example, we just add 101, 102 here, and then this will give you a false because this subset doesn't belong to this set 1. So similarly, we can perform is superset checking. Here we just turn it to a is superset to check whether this subset is the superset of set 1. Of course, that is not. So that will give you a false. And then we just use place it by a superset. So that will give you a true. So that means this set is actually a superset of this set 1. The next thing that I'm gonna show you is the comparisons operators. In many cases, the comparison operator will be used to control the flow of your program. So let's say, for example, we have a equals to 1, b equals to 2, and then c equals to 3. And then we have the comparison operator that is equal. That is to check whether a is equals to b. And of course, this is not. So the other comparisons operator is that a is not equal to b. So yes, a is not equal to b, so it will just provide you a true. And similarly, we can also have a to check whether a is larger than b or a is smaller than b. So because a is not larger than b, so it will just give you a false, and then because a is less than b, so it will just give you a true. And finally, we can check also whether b is larger than or equals to c. Oops, say for example, we just provide a 2 here, and it will return you a true. That is, b is larger than or equals to c. The comparison operator also work with letter or strength. So they will just compare the letter or strength by using the ASCII table. So for example, here we want to check whether the letter X is not equal to letter Y. And then because they are not equal, So it will give you a true. And then to check whether x is less than y in the ASCII code table, that will return you a true because x in the ASCII table is 170 and then y is 171. So that means y is actually larger than x in the ASCII table. Cool. The next thing that I want to talk about is the flow control. In order for us to write useful program, we almost always need the ability to check conditions and change the behavior of the program accordingly. In more sophisticated programs, we probably need to have more complex structures in our program. And there are three key types of flow control structure in Python that includes the loops, branches, and functions, and we will cover them one by one. The first thing that I want to show you is the branches in flow control. By using the conditional statements in Python, we can create different branches to control the flow. And the conditional statements are handled by if statement in Python. To create a if statement, we need to have, say, condition statement. Say, for example, we have some condition that is equals to true, and then we provide a if statement that there's some conditions, and then use a colons to define the branches. So inside these branches right here, we are still within the if statement branch. So for example, the sum, I just want to print the, yes, this is inside the if statement. So here you can see that there's an indentations right here. In order for us to keep the code within this if statement, we just need to provide an indentation. So everything here is inside this if statement. In order for us to break the if statement, we can just leave out the indentation. So this is this is outside the branches. So let me show you the results. Okay, you can see that because this sum condition is satisfied, is true. So within the if statement, we will print out, yes, this is inside the if statement. And then because by pulling out the indentations right here, this is outside the branches. That means no matter this if statement is satisfied or not, we will just print this statement. And let's say, for example, if we have a false, so because the if statement is not satisfied, is false, that means we are not going inside this if statement. So we just print out the hi, this is outside the branches. So let me go through another example. Say, for example, we have an a equals to 20. So if a is equals to 20, just print yes, is it equals to 20. And then say, for example, we have a condition is 10. So unless the a is equals to 10, it will go through these branches. And in order for us to add the one more branches here, we can use else. I mean, if a is equals to 10, just print this statement. Otherwise, that means the else, we just print no, it's equal, it doesn't equal to 10. So because a is not equals to 10, so it will not go through to the first statements right here. but instead it will grow to the second branches. We can also extend the branches by using the else if. Else if, say for example, is a is equals to, check whether it's equals to 5, and then print yes is equal to 5, and then the result is that under the else statement, no, it does not equals to either 5 or 10. So say for example we have a 20 here, so no, it does not equals to 5 or 10. So say for example if we have a 10 here, so it will just go through the first because it satisfies the first condition, so it will just go through the print function. Yes, it equals to 10. And similarly, let's say for example if it equals to 5, and then it will just ignore, because this condition is not satisfied, it will check the next condition, else if, that is whether this condition is satisfied or not. Because a is equals to 5, so yes, it will print the statement yes, it equals to 5 here. So by using the else if and else, we can extend the branches. The next things that I'm gonna go through is loops. Loops are another types of flow control that involve repetition of instructions. There are two kinds of loops in Python, that is the for loop and the while loop. A for loop is used for iterating over a sequence, and while a while loop is used to continue executing the same instructions over and over again until certain specific conditions are met. So let me show you an example to see how we can use for loop to extract each of the item from the list. Say for example, we have item 1 here, item 2, item 3, and then we use a for loop that is for item inside in this list. And then we just print out the item. So what we just done is that we use a for loop here for item. Item is a variable inside this list. This list is a sequence of data. So we print out the item variable. We can assign another variable name. It doesn't matter. Say for example, we want to print out the x. We assign the x variable, and then we print out the x. And so what we are doing is actually that we pull out this item from the list one by one. So the first item is item 1 here, and then because this is not the end of the list, so we just repeat this loop to go to the second item here. So x will become item 2, we print the item 2, and then the next thing is the item 3, and then we print out the item 3. And that's the end of the sequence. So we break this for loop. Instead of providing a list, we can also use a range to provide a sequence of number into this for loop. Say, for example, from 0 to 4. So we have this for loop, and then we just print out the result. Here you can see that the starting sequence is 0, and then 0, 1, 2, 3, 4. Here the ending is just we need to plus 1 from this 4. That means we have a 5 for the ending parameters. Another functions that I want to show you with the use of for loop is the enumerate. Enumerate functions can provide you the index and also the value of the item under the list. Say for example, we have the I and item, use a comma to separate the index and the value of the item. And then we use the enumerate functions by passing it a list into it, and then we can just print out the I and item. So by using the enumerate functions within the for loop, we can return the index for each of the value inside this list. Say for example, the item 1 is with the index 0, that is the value is the item 1, and item 2 that is the position is 1, and then the item 2 that is the value, and so and so. Sometimes, instead of providing a sequence of data, we want to continuously execute some codes until a condition is no longer satisfied. In that case, we can use a while loop. So here you can see that the print statement inside this loop is keep repeating as long as this condition is true. That means within this while loop, if the condition statement is true, these statements, print functions, will continue. So until this condition statement is no longer satisfied, we will just break the loop. Maybe let me give you also the I value in order for you to have a better understanding how this for loop works. So let's say, for example, I is equals to 0. That means it is less than 5. So we just print out this statement and then we just add 1 to it. So now we have I equals to 1. I equals to 1. So I is less than 5. So keep looping. So, and then we add 1 to the I again. So that I becomes 2. Keep looping. And then 3 and then 4 until I is equals to 5. That means 5 is no longer less than 5. That means this statement is false. So it will break out the while loop. Apart from branches and loops, we can also use user-defined functions to control the flow of your program. By definition, a function is actually a block of code which only runs when it is called. So you can pass your data known as parameters into the functions, and a function will then return you the results. So a function is actually a very powerful and useful block that you can use it from time to time, which perform specified functions. The main reasons that we want to create a function is because we or others can reuse it in different programs. So there are two types, in general, there are two types of functions. That one is the built-in function. So for example, the print function, the uppercase function, the lowercase function that we mentioned before, and then the user-defined functions. For user-defined function, it's more like you create some functions for you or other programmers to use later on. To create a user-defined function, we just need to type the def and then provide a name to it. So for example, the print something, and then with a round bracket, and then the colon here, and then that's it. So for example, we want to print the hello world. So these are the print hello world is within this def function. So for example, we just call out this print something. And this is how we create user-defined functions by providing a def, a name to it, and then round bracket and colon, and that's it. So say for example, let me create a countdown function here. Say for example, we have a parameters x here that we would like to pass into this function. And we have the x is, make sure that it's an integer. So we just use the integer function. And then if x is less than 0, then we will just print, please provide a positive number to the users to make sure the user provide a positive number. Else, that means we have a positive number. While x is larger than 0, we will print the x, and then x is equals to x minus 1. So let's go through this function line by line. So first of all, we just create a countdown functions by providing a name to it. That's the countdown. And then we need to provide a parameters inside to this function. So for example, if we provide a 5 here, and then we just make sure that that is an integer, and then x is equals to an integer of 5, that means this is 5. If x is less than 0, 5 is not less than 0, that means we are not going to print out this statement. And then else, that means because 5 is a positive integer, that means we will just go through this while loop here. So because 5 is larger than 0, so we just print 5, and 5 is minus to 1, that is 4, and again 4 is larger than 0, and then this while loop is keep looping. So let me show you the results. So here you can see that we just call out these functions by typing the name, and then provide a parameters into it, that is 5. So x now is equals to 5. And then just go through what I mentioned before, and then 5, 4, 3, 2, 1. And that's it, because the while loop is break, and then the function will be end. Because the function here help us to perform some tasks. So sometimes we want to return the result from the functions. Say for example, here we just return x, that is the values of the x after going through all these code. So in order for us to get this value back from these user-defined functions, we need to use the values equals to countdown 5. That means it will return x as the value. So that means this is the x equals to the value. And then let me print out the value. So the value is 0 here. So you can now see that so after running all these code within this user-defined functions, we can use a return to return the result back to the main program. To provide you more information, actually there are two types of variables, that is global variables and local variables in Python. So global variables can be reached anywhere in the code, and a local variable can only be reached in the scope. So here, because x is defined within these user-defined functions, that means x is a local variables. So in order for us to transfer these local variables back to the main program, so we need to use the return function here. So say, for example, if we have a variable that defines outside this user-defined program, say, for example, we have y equals to 101, that is a global variable because this is in the main program. So that means no matter whether we pass these informations to the countdown or not, to the user-defined function or not, we can still print out the y because that is a global variable. So here you can see that the y can be printed within these user-defined functions. So let me repeat. A global variable can be reached anywhere in the code. That means even we define this y outside these user-defined functions, we still can access the value of that. If we do not return x here, say for example, we cannot print out the x because x is a local variable. Here you can see that x is not defined in the global environment. The final things that I want to show you is the importance of order of code. Here you can see that we define the function at the very beginnings, and then we call out the functions right after we define the function. So let's say, for example, if we call this function before we define the functions, let's see what happens. So you can see here, because the function is not defined yet, so we are unable to call the function. So a very good practice is that we always have to remember that we define the functions at the very beginnings before we call the function. So the best practice is to define the function at the very beginning, and then we write the main program at the bottom. Another best practice is to create a main check statement. In Python, very often we write the modules and execute it within the modules directly. However, sometimes we want to import another modules to support our modules. In these situations, to avoid running the main program from the imported modules, we need to use the main check. This main check helps us to execute the main programs only if we want to run the modules directly, and make sure that the main programs will not be executed when the module is being imported by others. Let me show you an example. Before we go into the details, let me show you the difference in double underscore name when we run the modules directly and when we import the module. Here is the simple example. So we just print out the double underscores name in the useful modules directly. So you can see this is a double underscores main. So when we import these useful modules, and then you can see that we just run these executions, and then you can see that the double underscores name is changed to useful module. Therefore, by checking the double underscore name, we can easily control that the main program from the imported modules will not be executed. So let's go back to the useful modules. Here we have a power functions. So let's assume we do not use any main check to run this program. Okay, here you can see that you have just used this function in useful modules, which is the power functions, and then this is the execution part in the useful module, and result is 8. So there should be no problem because we just directly use within the useful modules. So let's see what happens when we import these useful functions. And here, because we import that useful functions and we want to use the power functions within the useful module. And you can see that right now, we also not only we execute this main program within this new program, but we also execute the main program in the useful modules. And this is not what we want, because we just want to import the useful functions, or I should say, because we just want to import the power function from the useful modules instead of importing the main program from the useful module. In order for us to avoid that, we can just put in an if statement for the main check. So we changed, we're just adding one sentence, one if statement right here, and then you can see the difference. You can see that now the main program in the useful modules are not executed, and then we just execute this part, the main program, within the new program. Therefore, it is always a good habit to apply these main check statements so as to allow other programmers to use your function without executing your main program. The next thing that I'm going to show you is how we pull out data from different types of files. In Python, a file is categorized as either text or binary, and the difference between the two file types is important. Text files are structured as a sequence of lines, where each line includes a sequence of characters, such as HTML, XML, and text files. And a binary file is any types of files that is not a text file, such as PDF, image files, and video files. Because of their natures, binary files can only be processed by an applications that know and understand the file structure. In other words, there must be some applications that can read and interpret the binary file. In order for us to work with a text file in Python, we can use the built-in open function. The open function will return a file object, and commonly we just need to input two arguments. The first argument is the name of the file, and the second argument is the mode, which is the way that you will work with the text file. There are 5 common types mode, including the read mode, write mode, and pen mode, and the combinations of the modes. The read mode is to read data from a file. The write mode is to write data into a file. In this mode, data is in the existing file will be overwritten. The append mode is to append data into a file. In this mode, data will be appended to the end of the file. So let's start with an example to see how we could use different modes to communicate with our text file. First of all, we set up a file object first, and then we try to use the open function right here in the file. The file, the first argument that we have to put is the uh, file name, and then for the second argument, we just need to put in which mode that we are going to use to communicate with our file. So here we just already with this simple sentence, one sentence or one sentence of code, so we can just simply open the file and then open the text document files and then put it into a file object. So every time we have to close this file properly in order for us to avoid any problems. So we just within these, so this is the open statement, and then this is the close statement. And then within this statement, let's print out what we could have in this, what we have in this file object. So we have the file object. However, this is just an object, so you need to use the function inside these objects in order for us to know what's inside this test document. So with these 3 simple codes, you can see and just extract the the data within this test document, and there are 3 sentences, including there's 3 sentences inside this test document. Instead of using a file name, we can actually use provide a file path with the names in this. So this is the file name with the full path, and then we can actually do the same thing by replacing the file name with this full path. So you can see there's no difference. One point we should note that is the close function here. It is important to understand that if we do not close the objects properly, any further attempts to use the file will be failed. But sometimes it is very easy for us to forget to put in this close statement. In order for us to avoid the problem, we can use with statements to help us to solve to address these problems. So here we just put in the with statement, and then we similarly we just copy this open file functions, and then us these file objects. So there's no difference by assigning these open file objects to these file objects variables. So here just put the code right here, and then you can see there's no difference in between this code and this code. And you can also see that here we don't necessarily just put these close functions right here. We can simply just put it right here, and then with the with statement, it will help us to close it appropriately. So you can see the results are the same. There are several ways that we can read the data from the file, and here we just use .width functions to read everything from the files. So actually, we can read it line by line by using .width lines function, or on the other hand, we can use a loop to help us to do that with the file. So here we just use a for loop for line inside these file objects. And then we just want to print out a line to show results that they are actually similar. You can see that the with file function is that we just read everything inside this data file. And then here is that for the with lines, here we just provide you a list of these sentence 1, sentence 2, sentence 3. They just treat the first string as the first string as data 1, and the second string as the data 2, and so and so. And then finally, we can also use a for loop within these file objects because there are free data in this test file, so that this for loop just runs 3 times. This is sentence 1, sentence 2, and sentence 3. So let's see how we could write something into this test document. Just copy sentence first. So we change the R to W, and then the file objects right here, just change the with line functions to another, the right functions. So here you can see that we are going to write one sentence, write a sentence into this file. The /n means that there's new line after this this sentence. So because everything will be overwritten by this write mode, so in order for us to keep the original data and just provide 3 sentence to write inside these objects, and then I use these these open functions to read the results to you. So here again, this is sentence 1, sentence 2, and sentence 3. For example, I just change this to sentence 5. See there similar results. But very often we do not want to overwrite the existing data into the file. So here we can change to the append mode to see what happened. And you can see that with the append mode, the data right now will be appended to the end of the file. Apart from the test file, we can also use Pandas to help us to pull data from other types of files. Pandas is one of the powerful and flexible Python packages that allows us to work with text and binary files such as Excel, CSV, and many other types of files. Functions like the Pandas with CSV to CSV with Excel to Excel methods enable us to work with files effectively. We can use them to save the data enabled from Panda objects to a files and load them later as a Panda data frame instance. In order for us to use Pandas, first of all, we have to import these modules into the program first. So here we import Pandas as PD. So we use the PD doc with functions. Here we would like to show the CSV first. So we just with CSV, and then we provide the data name, the data file names, and then here because we do not have we have a header, so we put a 0 right here, and then we also have a column index that is That's the first column is our index. So we just put 0 here. It just in any case, if you do not have any header, you can put none here. Just in case you do not, you also do not have any index columns, you can put none as well. But here we have our index columns in the first row and the first column, and then we have the header in the first row in the in the CSV file. So we just with this first, and then we try to let me show you the first few rows by using the head functions right here. So this is the first 5 rows in this data CSV files. So once you use these Panda files that imports the CSV, you will have a data frame that contain all this data. And because you can see that we have some NaN right here, which is uh, redundant, or we do not want this data, so we can use in Python, in Pandas, we can just use drop NA to drop this row very easily. So access equals to rows. And then in order for you, you can either just show the result in the screen, or you can actually change this data frame by using in place function. If you set it as a true, that means you are going to remove this row in the data frame. However, if you just choose false and it just shows you the results, but without actually removing this row. So here I just use true right here, and then you can see the results once again. In place equals to true. Oh, here drop NA. Yep. Right now you can see that there's all the rows containing the NA, it just been removed. So finally, we can use df-doc2 CSV file to save the um, uh, to export this Panda into a CSV file. Just type in the file names, and then that's it. Instead of working with a CSV file, sometimes you might want to work with the Excel file with the .xls and .xlsx files. So in order for you to do so, you have to install the XLRD in order for you to read the Excel, and the XLWT in order for you to write the Excel with the .xls file in order for you to exports to the .xlsx files, you have to install the OpenPyXL file, that module. So let's take a look on the functions. So actually, this is very similar, but you just change the CSV to Excel, and then these CSVs to Excel. Oh, so that should be XLS, and then this to change CSV change to Excel, and then this CSV change to XLS, and just one. Okay, that's it. And then just change it to XLX, XL, XLSX, XLSX, and then just one. And that's it. So right now you should be able to communicate with your CSV file, XLS file, and also the XLSX file with the Panda module. Once we pull out the data from Excel file or CSV files with the use of pandas, data will be in data frame formats. In order for us to work with these data, we need to use some built-in function within the pandas. There are two commonly used methods to extract data in Pandas, which are .loc and .iloc methods. The .loc is label-based but may also be used with a Boolean array, and the .iloc is integer-based but may also be used with a Boolean array as well. So let me show you an example to see how we could use these two functions. First of all, we import the pandas, and then we use the .with Excel files to read the data in this data Excel file. So we have a header, and also we have a index column. So we just equals to 0 and also equals to zeros to represent that we have the header and also the index column. So and then we transform everything into a data frame. That is the DF right here. Before we start, we can use several functions to allow us to have a better understanding of the what kind of data is inside this data frame. So say, for example, we can print out the first 5 row, and also we can print out the last file by using the .head functions and the .tail function. Here's the first 5 row, and this is the last 5 row. And we can also use the doc size functions and doc shape function and doc and dime functions to return the total number of the data and to return the number of rows and number of columns and also the number of dimension. So this is the other structures of the data frame. Now let me show you how we can use the .loc function. In the .loc functions, we can just simply put the row index and also the column, the row name and also the column names in order for us to identify the data that we would like to have. So say for example here we want to we want to put out everything in the for all of the columns, and then we just would like to have this CKH holdings row. So we just put the name in the row and then put the colons. That means we want to have the everything's inside every columns inside this row. So we just print out the extract data and see what we have. So right now you can see that we are able to extract the CHK's holdings informations that represent all of the columns inside it. But of course, you can see that these by using these methods, the row has been the columns has been transposed into 9 rows. But never mind, we just would like to show you how we could extract the data from this. So we can also placing, say for example, we just would like to have this value, and then we can also just identify the columns that we would like to have. So this is a 52.7 right here. And in addition, we can also pull out some additional column by providing at least to them to the column argument. So for example, we would like to put out these 2 column value from this CKH holdings. So you can see that we can actually add adding two columns by providing a list to them, and we can also similarly we can also just give multiple input into the row. So here we extract 2 rows with 2 elements. So this should not be too hard for you to do so. Instead of getting the information from this data frame, we can actually pass informations in this data frame as well. But similarly, we can just simply use this .loc function. Here we just firstly identify this element first. Say for example, we would like to assign new values to it. So we can just instead of and just use these equals assignments to assign a new value to it. Say for example, this is 54 right now. And let me show you once after assignments the value. So right now you can see that after the assignments, this is actually updated to 54. Let me show you clearly that I'm putting a data head right there. So now you can see that the value has been changed to 54. Similarly, we can use the .iloc functions to do similar work. Again, this is the first argument is the row, and the second argument is the column. So say for example, we would like to extract the first row, and then we would like to extract everything. So here we have a similar results with the with this iloc functions. Say for example, we just would like to get the first element. Here we go. Similarly, we can also provide a list of integers into it as well. So for example, we just would like to have the first row and the third row. Like to have, say for example, just the first two element. Now right now you can you can see that we extract these first row, first two elements, and then the third row, the first two elements right here. We can also use slides to help us to do similar work. Say for example, we would like to have the first two row and then with the first two element. So here we go, first two row and the first two elements. So for example, right here, we would like to have the every second row, and then we nice to help us to do that as well. So every second row. Similar to the .loc functions, we can also assign values to it. So say for example, we just get the first element right now. That is 52.7, and we just assign a new value to it. Just say for example again 54, and yeah, I can show the result. So right now you can see that the first element has been changed to 54. Once we know how to use indexing in Pandas, we can now perform some descriptive statistics in Pandas. A large number of methods in Pandas can help us to compute the descriptive statistics and other related operations in data frame. And let us go through the most commonly used functions in this video. So here, let's load the database first. and then we print out the first 5 rows for you to understand the database or data set that we have. Here, this is the some stock informations, and you can see that there's few several NaN right here. So we are going to let's remove it first. df dot job NA and access. We just want to remove the row that contains NA and make sure that in place is equals to true. What we have right now. Okay, now the NA has been gone and then has been removed it, and so we have for every row we have the stock name as the which is the index, and then we have around a several. I guess that should be more than 8 columns for the stock informations, and we have the stock price and so and so. So let's see what we could calculate with the descriptive statistics. So say for example, we just would like to compute the statistical informations for the first row. Or just would like to have the number of counts in the first row. See what we have. So we have for the first row we have 50 count, and then we can also use the sum function to sum up the first row. That means sum up the stock price for each of the elements, and you can see the results right here. And we can also calculate the mean. Calculate the mean of the first column, and this is the result. We can also calculate the median, and this is the median price of this first row. And we can also calculate the standard deviations for the first row. That is the stock price of this first row, the standard deviation. And we can also calculate the minimum value or return the minimum value of the first row. This is 2.36, and similarly, we can return the maximum value in the first row. We can also make the whole column to be absolute value. I mean, we absolute the whole column. So you can see that there's a whole column is with the absolute value. Of course, because the stock price is has to be positive. So this is just the same, the results, but it doesn't matter. I just want to show you how to use the absolute function. And then we can use the product functions to just products for each of the elements right here. So that should be 52.7 multiply the 7.45, and then multiply this one, and so on. And we could have a cumulative product. That means 52.7 times this one, and then these two elements will then add up to these 3 elements of the products of these 3 elements. Similarly, we can have a sum accumulated sum. What is accumulated sum is that just these elements add these elements, and then these elements, and then I should say, let me show you. This is 50.7, and this is the first element, and then the second element is that 52. 7 plus 775, and then 50.7 plus 7.45 plus 43.9, and so and so. And this is the accumulated sum. And then the accumulated product that I just showed you is the, just change it to a multiplier. And then, so this is not so hard. Apart from the descriptive statistics such as count, sum, and mean, there are some other statistical functions which we can apply on Pandas data frame objects. They include percentage change, covariance, and correlation. So let me show you an example to see how we could work with the percentage change, covariance, and also the correlations. Here I just download the NetStep index, and the value of the NetStep index. So let me show you the first 10 row to see what kind of data is that that's containing inside this NetStep data frame. So here you can see that we have the open, high, low, close, adjusted codes, and also the volumes that inside this NetStep database. So let's say, for example, if you want to calculate the percentage change of the closing price right here. So we can just, let me copy this first. And NetStep, and then there's the percentage change of the close. And here, let me get more clear. Percentage change close, and then we just have the NetStep data framework, and then we just select everything inside the close column. So, okay, that's good. So once we select this this close column, right now we can actually assign a new column. I mean, insert a new column that we call it percentage change column, and then with the using the percentage change function, that should be the CT change. Okay, that's good. So let's say, for example, I just want to show 5 columns for the original data frame, and right now I want to show the 10 columns for the new data frame. So you can see that right now the data frame has one new column that's called the percentage change. And then we just use the closed price for each of the day to calculate the percentage change. Because for the first elements, there's not no reference for the closing price. So that means that the Python just help us to give an NaN to it. And then this is the percentage change by around 0.4% for this day, and so and so. Python is also very smart to help us that, say, for example, we have an NaN or the null value on this row. So they just avoid to calculate the percentage change by infinity, so they just provide there's nothing to change that in these days. And also Python is very smart that they just let these days and they just jump across these, I should say, they just jump across the null value columns, and then by using these two value to calculate the percentage change for this one. So so as a result, um, they help you to skip these null value columns, null value row, but at the same time they help you to calculate by skipping this null value. The next things that I want to show you is the covariations. So say for example we have a closed closing price, and then we would like to know whether the opening price is related to the closing price. So we just extract the column of the open price right here. And then we use the covariation functions to see whether there's a positive correlations or covariations or negative covariations. So we just call out these call functions and then put the close price right here. And then you can see the relations right here. So this is the relationship between the opening price and also the closing price. One thing I should remind right here is that covariations tell us whether both variables vary in the same directions only. So there's no meaning of the covariations numerical values, and only the sign is useful. So in order for us to know more about the magnitudes or the how strong the relationship between these two values, we will use the correlation function. So here we can just change it to zero out as the correlation functions. So right now you can see that this is very strong. They are very strong correlated, the opening price and also the close price. The last thing that I would like to show you is how to create a correlation coefficients table. Let's say, for example, we have a subset of NASDAQ close right of this NASDAQ database right here, and then we just pick up the opening price and then the high, highest price in the day, and then the lowest price in the day, and then we just get also the close price right here. Right here, we create a subset of the NASDAQ from the original NASDAQ database. So here we just type in this correlation function and then print out. And you can see the result here is the correlation coefficients table. The next topic that I want to talk about is the missing data. Missing data can occur when no information is provided for one or more items or for a whole unit. Missing data is always a problem for machine learning and data analytics. Very often, it causes a lot of issues in the accuracy of model predictions because of poor qualities of data caused by missing values. In these areas, missing value treatment is a major point of focus to make their models more accurate and valid. And sometimes many databases simply arrive with the missing data, either because it exists and was not collected, or it never exists. None is native to Python and is an object that is often used for missing data, while NaN is not a number, which is a numerical value, which is used in Pandas to represent the empty or not values. Pandas treats nums and NaN as essentially interchangeable for indicating missing value of null value. There are several useful functions for detecting, removing, and replacing null value in Pandas data frame. So let me show you an example to see how we deal with missing data. So first of all, we just import the pandas as PD, and then we read a CSV file. And this CSV file actually contains the NASDAQ data in the past year. So we have the header, and we also have the index column. So we set it as the first row as a header, first column as the index column, and then we extract the value from this data set. So let's see what we have in this data set. I just want to show you the first 8 row to give you a feel of what we have in this data set. So we have the open, high, low, close price, and then we have some time series of data, and then there's some missing data right here. So let me show you an example to see how we deal with missing data. So first of all, we just import the pandas as PD, and then we with a CSV file. And this CSV file actually contains the next step data in the past year. So we have the header, and we also have the index column. So we set it as the first row as a header, first column as the index column, and then we extract the value from this data set. So let's see what we have in this data set. I just want to show you the first 8 row to give you a feel of what we have in this data set. So we have the open, high, low, close price, and then we have some time series of data, and then there's some missing data right here. Of course, we can go through the whole data sets by observations to see whether there's any missing data, but actually Pandas also provides functions to let us to do so. So we can use a function is null or not null to find out whether there's any missing data. The values or the outputs from these functions just will return the Boolean values for this data for the whole data set. So say for example, we just assign value chat is null, and then we just is null provide the is null function, and then so if that is null, and it will return a true, otherwise it will return a false. So we just check the first 8 row. So you can see because in this day, March 24, you can see March 24 is null, so it returns a true right here. So the other is just false because that's not null. Also, we can check the other way around by checking whether it's not null, and not by using not null function, and then just print the chat should be not null, and then we just I just provide you the first 8 row in order for you to know what not null returns. So you can see that because this day is not null, so that's not null. So this is as a result it indicate a false. So the other is that because it's not null, so just return a true on that. So once we confirm there are some missing data, so now we have to decide how we are going to deal with the missing data. So the simplest way is that we just take out this row by using the drop NA. That means we are going to take out any row that contains an NA. So access equals to 0 means the row, and then in place equals to true. That means we are going to replace the whole data frame. So right now we just print out the function, print out the results to naturally know what we've just done. So we provide the first 8 row as well. So right now you can see that the March 24 is gone because we just used the drop NA to drop this to drop the whole row from the database. However, sometimes the data is very valuable, so instead of just dropping all of the row containing NAs, so sometimes we just would like to fill in some value, and we can use fill NA functions to fill in by either value or by methods. So let me show you an example right here. So first of all, we just drop the NA first, and then say, for example, we would like to fill in the value by using mean, or fill in the value by using median. Just extract the I calculate the median and calculate the mean of the um, of the of all for every column. So this will, by using this dot mean function and dot median function, that will return the mean or median of the open price, high price, low price, and so and so. And then we just use the fill NA function by providing the value. Let's say, for example, we would like to fill it with the mean, and then, yep, we need to make sure in place equals to true. So let me show you the results. So you can see at first, March 24 is NaN, and right now March 24 is filled with the mean of this column, of the open column, of the high column, low column, and close column, and so and so. And we can also just change it to the median to fill in the data. So right now you can see that March 24, that is filled with the median. Of course, we can fill in other value that you feel they are most appropriate. Say, for example, if you think that 0 is the most appropriate, then you can just fill in 0 or so and so. So this value is just what you are going to replace in for each of the column. But sometimes we might just want to fill in these values uh, to a specific column. So, for example, for the open pies, we would like to specify it. We just would like to use the in to replace this value, and the medians to replace the high, but rather not just assigning all of the rows are using the mean or median. So in that case, we can also just make it specifics to the column. So we just here we just first of all we just call out that column first uh, in order for us to assign values to this column. So here I just use an example. I would like to replace the NAs just in the open column. So here, let's say I would like to fill the NA with the median just in this open column. So I just move this one first. So you can see that, oh, sorry, I just give a string to it. So right now you can see that we just assign the median for the open column instead of just assign all the median to all of the columns, and others just still keep NaN. Instead of filling the NA with a value, we can actually also fill the NA with a methods. So there are two methods that can be used in this fill NA function. First of all, just fill NA, and then method one is called the forward filling, and the other is called the backward filling. So let me show you the backward filling first, and then in place equal to true. Second, remove all of them first. So this is the back filling. So here you can see that the 34, the March 24 right now just pick up the March 25 values and then just copy into this row. That is the backward filling. That means this row is going to just put all the value from this, copy all the value from this row and then paste in this row. And then on the other hand, we can just use the forward filling. I guess you know the result. The forward filling is just we just put the value from the in the upper row and then just copy and place it into the row below. The last thing that I would like to mention is the interpolation. So sometimes we just would like to calculate the mean between this row and this row, and then fill in the mean into this row. So in order for us to do so, we just use the interpolation, and then we just fill in the value by linear methods. That means we use this upper value and then this lower values, and then calculate the mean between these two values. That means just add this number and add this number and then divide it by 2. That says goes to 0. And then we can apply this linear interpolation. So right now you can see that this row is calculated by the interpolations between this row and this row. So I hope now you know some basic skills to deal with the missing data with the Pandas functions. The next topic that I want to go through is to show you how to work with multiple data frame in Pandas. Pandas is mainly used for machine learning in the form of data frames. Once we use Panda functions to extract data from our text file or binary files, the data will be formed as a data frame, and Pandas further allow us to perform various data manipulation operations. Pandas provides various functions to combine this data frame, and the most commonly used methods are merge and concat. We can use the concat functions in Pandas to append either columns or rows from one data frame to another. So let's grab two datasets to see how this works. Here I have two datasets. I just call it df left and df right. So let's see what we have inside this two datasets. We have 6 samples in the left dataset, and then we have 7 samples in the right dataset. So here you can see that in the in the left data frame we have the name of the stock, the symbol of the stock, and then just few more parameters. And then on the right data frame we have the symbol, volume, turnover, and so and so. Just to remind you that the symbols in these two datasets are different. So we have several common symbols, say for example, 1, 2, 3, 5, 1, 2, 3, 5. However, you can see that we have two samples right here, 6 and 11, which are not appears, which do not appears in the right data frame. So let's see how we can use the concat functions to append the two data frames together. So I just type in v and then stack. That means vertically stacking. And ed dot cat have two objects. One is left and one is right. So we always have to provide the access to it. 0 means that we are going to vertically stacking these two panda frame together. And I just sort it with a false. That means we are not going to sort anything. So let's see the results of this vertically concatenation. So here you can see that we just stack these two data frames together. However, by using these concatenations, vertically concatenation functions, you can see that the symbol right here, because we have a common name in these two data frames, so this will automatically help us to group these two data frames with the same symbol, with the same column name together. Similarly, we can just change it to a horizontal stacking by passing 1 to the axis. However, when we stack horizontally, we want to make sure what we are doing making sense. Just like what I mentioned, there are some samples are not the same under these two data frames. Say, for example, right here we have to 001, 002, 003. So they when we concatenate them together, 001, 002, 003, the market caps right here is correct. They concatenating these two data frames correctly. However, when you look down here, say for example, for the Hang Band 00011, we do not have any market cap under the right table. So therefore, the market cap right here is not actually the market cap for the for these 0011. So that creates some problems right here. And in order for us to avoid these problems, we can use merge. In merge, we need to provide the merge key, and this merge key will help us to do some logical checking. And there are 4 types of join. The first one is the inner join, which will return the intersections of the keys from the 2 data frame. So let's say, for example, right here we have the inner merge, which is actually the inner join, merge, and then we have the left equal to the left data frame, right equal to the right data frame. And then we need to specify the name, the column name. Say, for example, have symbol is the common column name. So left on means that we need to compare this symbol on the left table. Need to specify the right on as well. Also, just call it the symbols. That means that this merge function will help us to check the logics in between this symbol in the left table and this symbol in the right table. So because this is the intersections of these two tables, you can see that the results only have 4 rows. That means we only have 4 common rows in these two data frame. That is 1, 2, 3, 5 here and 1, 2, 3, 5 right there. But sometimes we want to keep either one of these table as our main table. So in order for us to do so, we can use left join or right join to do that. So say for example, we can just provide how left, that means left joined. So here you can see that the left table is kept, and then the right table is appended according to this symbol names. So right now the logic is correct. The other way is that we can also use the right table as the main table, and then here you can see that we just keep this data set as the main table and then join the left table according to the symbol. So you can see that the sample size are the same in the result. and the result, and also this rights table. Sometimes we just want to combine these two tables all together, but with the logical checking. So, and just change the out to outer. So you can see that the two tables are combined together with the logical check. So this is the main reason why I like to use a merge instead of concat, so that the data frame is always logical. The next thing that I want to show you is to how we use pandas to deal with the time series data. While we are working with data, encountering time series data is very common. Data scientists love pandas for many reasons. One of the reasons is because it contains extensive functions and features for working with time series data. We can convert date and time text strings in pandas date-time objects easily by using the toDateTime function. So let's see how we can do that. So first of all, we just import pandas as PD, and then we with the CSV files, which contains the next step data for the past year. And so in this file, we have a header, but however, we do not have the index columns. So let's see what we have inside this data set. I just print out the first 5 rows for you to have a feel to understand what kind of data that we have. So we have the date, we have the open, we have the high, low, and so and so. However, when we extract the data from the data files to this data frame, this date is actually a string objects in the data frames. So let me show you what is the data type that we have. Which will show you the results of an object that's actually a string. So you can see the date is just a string, and the other types is a floating number. In order for us to convert these date string objects into a datetime types, we can actually use the toDateTime function. So first of all, we just we will assign the results to this date column, and then we just use just call out the datetime functions, and then what we are going to put is just put this column inside this toDateTime function, and then assign it back to the date column. So here you can see that the objects will be changed to a datetime types. So this is the result. And once we convert this date to a datetime type, we can use some datetime functions. Say, for example, let's just assign a new column called year, and then we just call out this column. Not this columns should be the date column, because and then because right now it's a datetime objects, we can use the DT datetime typed, and then just dot years to get the years from these datetime types objects, and then we can also get the month. Similarly, and get the date by changing it to month and day. So let's print out the first 5 rows to see what we have. Just ignore this time. And here you can see that we just extract the year from this date by using the .dt.year functions, and then similarly can just extract the month from these dates, from these datetime types, and then we can also extract the days. By having these three new columns, we can further manipulate our data. Say, for example, we can do some filtering functions here. Just say, for example, let's say we would like to filter the, just would like to take out all the value for month between, say, for example, 3 and 6. So that means we are going to get the 4 and 5 month, I mean April and May's data. We know the result. And we can also use group by functions to, say, for example, calculate the mean of the opening price. Just this nav step and then group by function. And then we just get the month column, the month column, then we calculate the mean of the opening price for each of the month. It's pretty typo right here. So right now you can see that we get the mean value of the opening price for each of the month by using the group by functions. So now you can understand that the toDateTime functions is a very useful function to convert the date and time string to datetime types objects in order for us to further manipulate the data. The final things that I want to show you in Pandas is the group by function. Sometimes we want to split data in the group and apply a statistical functions to each of the group in order to analyze our data in a more meaningful sense. Group by in Pandas can help us to do this easily. Splitting refers to a process in which we split data in the group and by applying some conditions on the dataset. And applying refers to a process in which we apply a functions to each group independently. Combining refers to a process in which we combine different datasets after applying group by and results into a data structure. So let's go through a few examples to understand the process involved in group by concept. So first of all, we import the pandas and then we use the with CSV files to read the database that containing in the CSV files. So in this CSV file, we have the header, but we do not have the index columns. So let's see what we have in this database. So we have some features or some attributes from this in these data frames that contains the date, open, highs, and so and so. And here, because this date is a text string object, so we just try, we will use the two dates time functions to convert it to a date time objects in order for us to further analyze the data. So you just convert it by using the two dates time function. And because we are going to just convert it, we just want to convert these columns to the date time objects. So and then we assign it back to this column. So and then we just extract the year, and also we want to get the month from these datetime objects. So we just doc by putting doc dt doc year. The doc dt means datetime. So and then here we want to get the month, and then we assign it back to the database. So here you can see we just append two columns right here. And we further just drop out some of the column in order to make this example more clear. We just drop the date, we drop the high, low, adjust those volume, and then access equals to 1 means we drop the column, and in place equals to true. Make sure it's taken in place. So you can now see that this data set is much more simpler in order for us to have a better understanding of the group by. Say for example, here we just using the group by functions to group the column for each of the month. Just so you just use these group by functions and then put the inserts the input column names, and then you can just have a different group right here, and then the result should be a group for the March, and then for April, for May, and so and so. And here I just print the groups to you by using dot groups, so you can have a better understanding of the results. So we have the January results here, and then that contain this data set, the original column. So for example, you can see that we have a third column right here in March. You can just check it. This is the first data set, and then we have second data set. We have the third data set that represent March. You can see the column right here. So that means the March group contain these columns, and so and so. Instead of grouping in a single column, we can also group it by multiple column. Here, say for example, we want to group the year and then also group the month. So here you can see that the first group is 2013 March, and then that have these date. Yes, this has these data sets. And then the second group is April 2019, and then have these data set and so and so. And this is how we can split data by using the group by functions. The next things that I want to show you is that actually we can apply a functions to each of the group. Say for example, let me show you the original data set first. Say for example, we want to calculate the mean for each of the year and also each of the month after the applying the group by function. So here we just put the column name right after the group by, and then dot mean, we can achieve the result. Just show you first and maybe 12 column. So you can see that this is in 2019 in March, we have this mean value in the open price and so and so. Instead of having one statistical result, we can also change it to dot aggregate functions, and we can add multiple statistical function in here. Say, for example, mean, mass, and mean. And here you can see that the results right now, we have the mean of the opening price, max of the opening price, and mean of the opening price in each of the month in the representing year. And we can also assign a name to it. Okay, for example, minimum is, and then this. So you can see here, we just change the name for each of the column by providing a dictionary in this aggregate function. We can also use a filter functions to filter out the values that that we doesn't want before we calculate this statistical function. So for example, here we use we put in the filter function here, and then we put a lambda x. Lambda x just means that it's a function that applies to every single element inside this data frame. Because these filtering functions, we just because this filtering function is right after the group by. That means first we group it by years and then by month, and then for each of the month and years here, we just use these filtering functions. We call it lambda x, and then for this opening price here, the x open dot mean has to be larger than 8,000. That means after applying these functions, there are some of the month will be gone. And you can now see only the data that contains the monthly means opening price is larger than 8,000 are shown here. Because the group by here is used for filtering functions rather than splitting function. So the results will still contains each of the row. So in order for us to better illustrate the result, we can just apply a group by functions to split the table. Here we have the opening price and then the mean. So now you can see that the dot filter functions right here is to help us to get rid of the data that on the monthly means that is less than 8,000. Or you can say only the mean value that is larger than 8,000 are remaining. The next topic that I want to go through is the Numpy. Numpy is the core library for scientific computing in Python. It provides a high-performance multi-dimensional array object and tools for working with these arrays. A NumPy array is a grid of values, all of the same type, and is indexed by a tuple of non-negative integer. The number of the dimension is the rank of the array. The shape of the array is a tuple of integers given the size of the array along each dimension. So let us go through a few examples for us to understand more about the NumPy. First of all, let's import the NumPy as NP, and then we can actually assign a tuple or a list in order for us to create a array object. So here we have the array from a tuple. So that is array np.array is the assignment of or you can say this is a conversion which converts this tuple into an array. So this is the array tuple, and then this is the list. So let me print this out. So I should show the tuple first. So you can see that there's no difference between this array object. Either passing a tuple or passing a list, that should be fine. Similarly, we can just create a 2D array by stacking few more rows. Say, for example, we have 1, 2, 3 in the first row, and 4, 6 in second row, last row, 7, 9. And here we have a 2D array. In order for us to know more to have more details about an array, we can use some built-in function by the NumPy. Say, for example, we can have the dimension and have the shape. We can also have the size, and can also have the for example, we would like to know what are the types of this array. So ndim just return you the number of dimension, and shape just return you the shape of the array, and size just calculates or return the total number of elements that inside this array. And this types function just return you the class of this array, which is a ND array. We can also use index and slice to extract the required elements. So for example, we just get the first element from this array lists, and then by using the indexing, and then we can also use slice functions to to extract the data as well. Here we extract all the rows, and then for the second and the third column. So typo. So the 0, it return you the 1, and then this one just get all the rows and then the second and third column. There are many ways for you to create an arrays to fit your needs. Say for example, and have a 0, 0 array. Say for example, we want to have a 3 by 3 matrix that contains zeros. So we can just call this function np.zeros, and then provide the size of these, the size of the array that you would like to have. So you can see we have a 3 times 3 array that contains all zeros. Similarly, we can just have a change it to 1, and then we can use the numpy.ones functions to create a 3 by 3 matrix that contains ones. Instead of passing a specific size into these numpy.one functions, we can also use the shape of an array to create the same size or same shape that contain the ones. We can also assign random values in a given shape. Just change it to these ones to random.random. And then the shape, we just say, for example, 3 by 3. So right now we can have a random value between 0 and 1 that is assigned in a 3 by 3 array. Dot random function right here returns a random value in a given shape. However, we can also change it to random wen.n, which will return a sample from their standard normal distribution in a given shape. And then the given shape is 3 times 3 right here. So this is the result. We can also change it to random integer. And then in order for us to return a random integers from low to high in a given shape. So here, say for example, the low is 0, and then the high is equals to 3, and then the size is equals to, for example, the shapes of the leads. Here, the low is an inclusive. That means it will include the 0. And high is exclusive. That means it will exclude the 3. That means because this is an integer, that means the random integer will only generate up to 2 right here. So here it is the result. We can also create a sequence of integer by using a range. So np.arrange. So say for example, we want to generate a sequence of integer from 0 to 20, and then the step is 2. So this is the sequence from 0 to 20. 20 here is exclusive. We also can use the line-based functions to create similar results. in a line space function, to specify the this is the starting value, this is the end value, and then we just specify how many equally spaced in between these two values that we need to create. So right now you can see that we have a similar results by assigning the space in between these two values. We can also reshape our finding. Say for example, we want to reshape the array, range array here to, say for example, because we have 10 elements here, we just reshape it to 5. That means we have 2 row and 5 column. In a newly created array. So right now you can see that the original array is reshaped into a 2 times 5 array. Instead of a reshape, we can also flatten the array. Flatten means that we are going to create a 1D array. So we just flatten this array back to a 1D array. So this is how we create an array. So let me show you how we can perform some simple mathematics function. So say for example, we have this log array. It's called. And then say for example, we want to add 1 to all of the elements in this array. And this is -1. And then say for example, we can also times 2 and then divide it by 2. And also power also can transpose the array. So here are the results. Say for example, we just add 1 to the array. And so you can see that the element-wise computation has been done. This is what we call broadcasting. So we also just use the -1 to, you just -1 for the array. And then we also multiply by the array by 2, divide the array by 2, and then power the array by 2, and then also just transpose array by using the doc_t. So just like what I've mentioned, this array, the array as array is element-wise, or similarly, the array times the arrays is element-wise. So these two results are the same. So in order for us to have the dot product, so we need to use np doc and then just provide the two arguments into this doc function. So you can see that right now we have the dot product between these two arrays. Similarly, we can calculate the maximum. We can also get the minimum and also get the sum, so and so. Because this just sum up all of the values. Oh, sorry. I should say because this is a maximum in this 3 by 3 array. So say, for example, sometime we might want to get the maximum for each of the row. So we just provide an access value to it. And here, similarly, we can just change the access to 1 in order for us to get the maximum value for each of the column. So here are the results. We can do the same for mean and sum, but I'm not going to show here. We also can have can use the sine function, cosine function in the Numpy. And say, for example, we use the numpy.py to call out the pi value, and then we use the numpy.sine to calculate the sine pi value. So similarly, we can do by replacing the sine by sine function. Similarly, we can also use an exponential function. For example, we can exponential 2, and then we can use the lateral log as well. Exponential function, we just lateral log it back. We can also have the square root function under the Numpy. So here are the results. So 0 for the sine function, and then -1 for the cosine functions, and then this 7.39 for the exponential functions, and then we just exponential, and then we just log it back, so we get back the 2, and then square roots 4, so that comes out the 2. We can also have a short function. Say, for example, we just change some value in order for you to show it's out in the after the sorting. Say, for example, we have this array, just np.short array assets, go to none. So this will give you the results of 1D array for sorting the number from the smallest to the largest. However, sometimes we want to keep the matrix. Just sort by the column element sorting by provide the access equals to 0, and similarly can just provide 1 for a row element sorting. So here are the results. We can also use Boolean functions in the Numpy array. Say, for example, we just need the elements that is larger than 2. So this is the Boolean functions. So you can see that because these elements right here is less than 2, so this is give you a false. because this element is less than 2, so this will give you a false as well. And we can also assign this boolean into this array, and then just will return you a 1D array that has the numbers or elements that is larger than 2. So in order for us to keep this shape, we can use a where function. Here we just provide the logic. That is, the array has to be larger than the elements in the array has to be larger than 2. If that is correct, we put it back the array value. If that is not correct, we give it a new value 0. So here you can see that because this is false, so we just give it a 0. Just give it a 0. The other, we just keep the original value. So that's all for the Numpy. And the next things that I want to go through is the Scipy. Numpy package provides basic functions for manipulating large arrays and matrices of numerical data. The Scipy package extends the functionality of Numpy. To be specific, Scipy is a library that uses Numpy for more mathematical functions. Scipy uses Numpy's arrays as the basic data structure and comes with modules for various commonly used tasks, such as linear algebra, integration, ordinary differential equations, and signal processing. In this video, we will use Scipy linear algebra modules to show you some commonly used linear algebra functions. First thing first, we need to import Numpy, and also we need to import the linear algebra from Scipy module. So let me show you how to solve a linear system by using the solve function. So let's say, for example, we have a Numpy array. That we have 3, 2, and 1, -1. This is the equation. And then we have the first equation is equals to 2, and the second equation is equal to 4. And then beside b. And then we can use the linear algebra function, which is called solve, to solve this linear equation. So here is the results. Here, because we have 2 equations and 2 unknown, so we have perfect solutions. But sometimes we might come across a linear system that have unbalanced unknown and equation. So let's say, for example, we have a 4, -5, -8. And then in that case, the solve functions cannot help you to solve the problems because the input needs to be a square matrix here. In order for us to solve this problem, we need to use the least square approximation. So here we can simply change the solve to least square. And C is the result. Now you can see this is the optimal result when we have the unbalanced equation and unknown. So right here we have the 3 equations and 2 unknown. and the result is best fit. So on the other hand, we can actually have more unknown than the equations, and the linear algebra functions right here can also help you to solve the problems by using the least square approximation. Apart from solving the linear system, we can also use these linear algebra functions modules to solve some to compute some inverse determinants or the P inverse. So let's say, for example, we would like to have the inverse of this A. Here I just change this to a capital A, um, which means matrix. And we can also compute determinant of this A. And when the matrix is not a square matrix, we can also use the P inverse to compute the generalized inverse. The linear algebra modules also provide functions to calculate norm. So change it to a vector, show you how to calculate norm here. So say, for example, we calculate the L2 norm, which provide you the ordinary distance from the origins to the point 3, 4 right here. So 5 is the result. And then we can also calculate the L1 norm, which provide you the longest distance traveled from the origin to the point B4 right here. And we can also calculate the L infinity norm. So by providing the Numpy infinity, so which give you the largest magnitude within the each of the vector, and under this vector, 4 is the largest value. In this linear algebra modules, we can also perform matrix decomposition. Say, for example, we have a 1, 2, 3, 4 matrix, and want to decompose this matrix. So we have a lambda eigen should be the eigenvalue and also the eigenvector. So this lambda is the eigenvalue and V is the eigenvector. Here's the typo. So these are the eigenvalue and these are the eigenvector. We can also apply the singular value decomposition here when we have a non-square matrix. Say, for example, we have this non-square matrix, and then we want to use the singular value decomposition. Here the function is SVD. So the U here is the left singular vector, and VH is the right singular vector. So this small capital letter S is just an array of the singular value. So in order for you to calculate, to have the singular matrix, we need to use another functions, which is the linear algebra here, diagonal SVD. Here we input the shape of the original matrix before the singular value decomposition, and then we just put in the diagonals matrix for this singular matrix. So let me show you the singular matrix. So the singular value array has been put inside this singular matrix. And you can use the dot product to get back the results for A. But I'm not going to show here. All right, the next topic that I want to go through is how we use the Scipy functions to perform a fast Fourier transform. We will use Scipy fast Fourier transform pack to show you how to compute the one-dimensional discrete Fourier transform and also the inverse discrete Fourier transform. Just a bit background of Fourier transform. It is used to convert signal from time domain into the frequency domain. By doing so, it does not only allow us to check the signal's behavior in the frequency domain, but also allow us to perform some function, such as filtering, that would be otherwise not possible to be performed in time domain. Because of such powerful capability, Fourier transform finds its application in disciplines such as signal and noise processing, image processing, and audio signal processing. And Scipys offer fast Fourier transform pack that allow us to compute the fast Fourier transform. In this video, I will create a sine wave with random noise, and then I will show you how to remove the noise in the frequency domain by using the FFT pack. So first of all, let's import the Numpy and also the FFT pack from the Scipy. And then let us create a sine wave with random noise. So first of all, we need to set up a time step for the sine wave. And then we need to create a time vector that contains all of these steps under this sine wave. So for each of the time step, we have a time vector that have the value from 0 to 10, and then in between we have a 0.05 for increment for each of the time step. So, and then we can just set up a sine wave by using the numpy.sine, and then by using the numpy pi function, and then times the time vector that we just create. So first of all, let me hide this row first and then print out the time vector for you to understand what we've just done. So here you can see that we just create a time vector that from 0 to 9.95, and then with the time step 0.05 for each of the time sequence. And then let me show you these two what is the 2 times pi times the time vector. And these are the variance value that we are going to pass inside this numpy.psi function. Remember, this is a radian value. And then let me show you the results. Here we need to run off it in order to have a better illustration of the results. So these are the values after the psi functions. So you can see that for every 5 steps, we have a quarter of the cycle, and then so every 5 steps we have another quarter of the cycle. So as a result, it takes us about 20 steps in order for us to generate one cycle. Since we have 200 points from this time vector, that means we will have about 10 cycles right here. To have a better illustration, we do not, I just try not to have too many cycles right here. So I also create a value right here called period, and then divide it by the period. That means we are going to um, create more points for each of the cycle. Because we divide it by 5, that means we are going to have 100 points for one cycle. So that means right here, because we have 200 points originally, so that means right here we will have a 2 cycle. So similarly, what I mean is that we are going to have 100 points here in order for us to have a complete cycle. And then because we have 200 points originally that we set in this time vector, so that means we are going to have 2 full cycle right here in this sine wave. So the next thing that I would like to have is to add some noise to this sine wave. So right here, I just add by using random.when to generate some additional noise to each of the time vector point. So we have a time vector on same size. However, if you remember that the psi function, the output of the psi function is values between -1 to +1. On the other hand, the random noise or the when n is a normal distributed values with mean 0 and variance 1. So in order to avoid the too much ramping up or ramping down created by this random noise, we will just multiply it by 0.25 to reduce the value of the noise. That's good. So right now we should be ready to perform the fast Fourier transform. So first of all, we just take out the psi FFT here, and then we use the pack that is the FFT Fourier transform of this psi function. And then we can actually get the amplitude by using the absolute value of this psi Fourier transform. And we can also create a power spectrum by the power 2 of the amplitude. And we can also use the Numpy angle function to get the phase spectrum of this Fourier transform value. So this is the power, and then this is the angle spectrum. That's good. And then for each of the amplitude and power, there should be a corresponding frequency. So in order for us to, to have the sampling frequency, we can use the FFT pack to generate that by using the FFT FLEQ function. So here we need to input the window size, that is the SIG box size. And then we also need to input the sample spacing that should be equals to our time step. So this will return the sampling frequency or the corresponding frequency for each of the magnitude or power. So let's take a look to see what we have in the amplitude and also the sampling frequency. So these are the value for each of the corresponding frequency. Say, for example, this should be the zero frequency. We have this 0.27 something value. And then 0.1, we have this, 0.1, we have 6.5 something, and then 0.2, 0.3, and so and so. And then you can see that these are the magnitude that, these are the amplitude for each of the corresponding frequency representing in these sample frequency array. Because we would like to remove the noise, so the peak frequency that contains the peak amplitudes are what we concern. So first of all, right here, we can actually stat them first. I mean, stack the amplitude and frequency together first. Sampling frequency. You use a Numpy array to stat them. So once we stat them, we try to find out the peak frequency right here. The peak frequency means that the frequency that we have the peak amplitude. So we just try to extract the first row right here and then find out the frequency, which let me type it first. So here we just try to find out the maximum amplitude arguments, the position of this maximum amplitude. So let me, I don't want to make it too complex. So let me say this is the maximum value position that is equals to these arguments right here. This is the this will return you the positions of the maximum amplitude, and then we just put it back to the maximum amplitude in order to this m frequency array in order for us to extract the sample frequency that is corresponding to this maximum position. So let's print out the maximum amplitude first. That is the position of the maximum amplitude, and then print print out the corresponding frequency. So the maximum amplitude position is at array, the third numbers of the array, and then the corresponding frequency is 0.2. So once we have this peak magnitude or the peak positions, we can remove the values, the amplitudes that are after this peak sequence. So say for example, right here, we just copy um, the psi functions that is after the Fourier transform right here, and then what we try to do here is to remove all the value, or I should say assign all the values um, that is that the corresponding frequency is larger than the peak frequency. So here is the corresponding frequency. So if there's larger than the peak frequency, we will assign it to 0. So let me show you the results. So here you can see only the corresponding frequency is less than or equals to 0.2. Their magnitudes are remained in this array. So by then we can have a filtered psi function in time domain. By using this inverse Fourier transform function. So here you can see that by removing all the amplitudes that have a corresponding frequency that is larger than this peak frequency, and then by applying this inverse Fourier transform function, and then we can get back a nice sinusoidal curve. So now you can see that by combining the fast Fourier transform and inverse fast Fourier transform, we can remove the noise in the frequency domains that would be otherwise not possible to be performed in the time domain. The next thing that I want to show you is the optimization package in Scipy. Scipy also provides optimization modules. In this video, we will go through a couple of examples to show you how to perform optimization with the use of Scipy. The Scipy Optimize package provides several commonly used optimization algorithms. The modules contains unconstrained and constrained minimization, global optimizations, least squares minimization, and curve fitting algorithms, and also Woods findings. In this video, unconstrained and constrained minimization is of our interest. The first thing that we need to do is to import Numpy and also to import the minimize from the Scipy Optimize. This Scipy Optimize can handle multivariate inputs and outputs and has more complicated optimization algorithms to be able to handle this. In addition, Minimize can handle constraint on the solutions to your problems. And you can specify 3 types of constraint that include the linear constraint, nonlinear constraints, and also the brands. So let us refer to the examples to define the objective functions, equality constraints, and also the inequality constraint, as well as the bounds. Let's define the objective functions, which is what we would like to minimize. So we have the objective functions. We have the parameters x here, and then x0, that is the x1 here, and x2 should be the x1 from the array, and then we just return the square of x1 plus x1 times x2. So that's our objective function, and then we can define the quality constraint. We input the x as the parameter as well, and then we assign x1, x2 similarly. Last thing is that we to return is the x1 the power 3, and then x1 times x2, and then minus 100 right here. Because for setting up of the constraint here, we always have to remember that we need to put everything from the right hand side to the left hand side. So we simply minus the 100 right here to make it as a to make the equation equal to 0, and that's what we like to do. So that's it. And then similarly, we can define the inequality constraint. So then the x1, x2, and then just return x1 square plus x2. Again, we just change this to minus 50 to balance the equations. Just like what I mentioned, I need to move everything from the right hand side to the left hand side in order for this inequality constraint that is set it larger than 0. That's that's what I've done here. So the last thing, so here we just defined the objective functions, and we also defined the equality constraint as well as the inequality constraints. So now we can move on to setting up the bounds. Say for example, have a bounds for x1, and also we have the bounds for x2. What we need to do is to put a tuple that is from negative 100 to 100. That is the bound, and then we use a list to put these bounds inside slits. And then we also need to create a constraint list. So we have constraint 1, so constraint 2. The first things that we need to define is the type. So here the constraint is equality types. We also have a constraint that is inequality types. And then the second thing we need to assign is the function. And what we try to put is this function, put it back to the dictionary that we just created here. So similarly, inequality. Like what we've just done for the boundary, we also need to put the constraint into a list. So this list we have the constraint 1 and also the constraint 2. And then finally, we need to give a initial value for this optimization. So as long as the initial value is a reasonable pair of the parameters, so let's say we have the bound from negative 100 to positive 100. So that means any pair of numbers that in between these two numbers should be reasonable. So we just set 1 right here. So now we can apply the minimization function. Minimize. The first thing that we want to put is the objective function. And then the second thing is the initial value. The third argument is the methods. And because we are solving the objective functions with the equality constraint as well as the inequality constraint, so XLSQP would be a good choice. So we need also set up provide the bounds parameters as well as the constraints parameters. So we can print out the results here. Oops, we have we missed the pass here. So here is the result. In the results, you should have the value of the objective function and its Jacobian, and also descriptions of the cause of the termination, and also the number of evaluation of the objective function and its Jacobians, and the number of iterations, and also whether the optimizations has been performed successfully or not, and also the solutions of the optimization. Instead of using the depth to define the objective functions equality and also the constraint, also we can use lambda function to do the similar work. So say for example, we have the objective function. We use the lambda x and then we define x0 is the power 2 plus x0 times the x1 right here, and then we also have the constraint go to a this and have the key here, just key this dictionary, and then we also we just need to change this quality to the lambda function. Yeah. Similarly, we have the x lambda here, and then that should be power 3 minus 100. Similarly, we have the inequality by using lambda function. Have the s- 50. See if I have any typo tuple here. Yep. There. So we have the with the initial value and also the bounds equals to -100 and to +100, and then we should have similar results. So you can see that we just replacing all of the codes above by using just 5 sentences. Yep. And you should have similar results right here. The final things that I want to go through for Scipy is the integration. In this video, we will go through a couple of examples to show you the Scipy integration module. Numerical integration is the approximations computations of an integral using numerical technique. The Scipy integrate subpackage is easy to use and allow you to apply many integration techniques, such as general single integration and general multiple integration. So first thing first, before we start, we need to import the appropriate library that includes the Numpy, and then also from Scipy integrate, we import the quad, the double quad, and n quad. This is for the single integration, and double quad is used for the double integration, and n quad is used for the n-fold integration. No matter which integration functions that you would like to apply, at the very beginning, you need to define the functions that you would like to integrate. So here we just define fx as the function, and then I assume we just need to apply a linear function. So I just return x right here. So that means our function is fx equals to x. And we would like to use the quad to calculate the area under this function. So area under this function called, so there are 3 arguments that we need to put in. The first argument is the function, and then you need to give the upper boundary and also the lower boundary. So the lower boundary right here, I set it as 0, and then the upper boundary right here, I set it as 2. That means we are going to integrate this function from 0 to 2. So let me print out the area. So here, after the result contains 2 values. The first value is the area, or is the integral that after you apply the quad functions. And then this is the absolute error terms. That means how much error that you have by using these integrations. So the smaller, the better. Similarly, we can create a functions for double quad, and by providing 2 variables right here, and then I just return x times y. So that means we have a functions that is the multiplications of these 2 numbers. So here we just calculate the area under these x times y. So again, we need to provide the function, and then we need to provide the boundary for the x terms, and then we need to provide the boundary for the y terms. So similarly, we can just print out the area, and then the result is 25, and then this is the error term. Apart from using depth to define a functions, we can also use lambda to define a function. Lambda x, y, and then the function is x times y. So similarly, we just copy this, and then you will get the same results here. Sometimes our integrations are not just constant. So the beauty of using the lambda instead of depth is that we can also additionally apply lambda functions to our constant right here. So what I mean is that, say for example, we want to have a function for the lower bound, and also we want to have a function for the upper bound. We can just assign a lambda function to it as well. So say for example, we have y, just a constant, just a variable y, and then we have a lambda that is y equals to y times 5, say for example, and then we can apply this function into the boundary right here. So this is the result. So here you can see that the lambda is very useful for non-constant integration bound. Furthermore, we can use anchor to help us to perform multiple integration function. So here we need to change it to one more parameter. Say for example, x times y times z, and then we need to provide a list of boundary for this argument. So say for example 0, 2, 0, 2, 0, 2, 0, 5, and 0, 5 here. So you can see the results right here. And similarly, we can also use lambda to perform similar function. So you can see we have the same result here. And that's the end of this video. If you have any questions or suggestions about what we covered in this long video, please feel free to ask in the comments section below, and I will do my best to answer. And if you enjoyed this tutorial, you can subscribe my channel, like the video, and share to anyone who you think would find it useful. And thank you all for watching.